My name is Guo Hong from China North Nuclear Fuel Corporation. And today my topic is research and development of thorium fuel for CANDU 6 reactors in Baotou. First is the generation introduction. My company has developed and produced many kinds of uranium-based fuels for research and test reactor and power reactor. Now we have two power reactor nuclear fuel produce lines. It's for CANDU 6 reactor and another for Alpha 3G reactors. Now we still have two other lines under construction. One is for AP 1000 reactor, and another is for high temperature gas cooled reactor. After 50 years of construction and development, our company has established a complete system for nuclear fuel element research and production. Now we have a specialized nuclear fuel research center, and we have advanced process equipment for chemical engineering, metallurgy, machining, welding, and radiation protection, and so on. In addition, we still have Enterprise Technology Center, Institute of Metallurgy, and Physical and Chemical Inspection Center. About thorium resources, the China is abundant. Its relevance ranked second in the world, and in Baotou, its relevance is about 20% of the national proven. About thorium utilization, my company researched and developed later in the 20th century. We have done some basic research works. And from 2007, we started again to research and develop thorium-based fuel. 2008 July, our company and Baotou Science and Technology Bureau signed a contract to develop thorium-based fuel element for heavy water reactor. 2009 June, the application on building up a research and engineering center for thorium fuel at CNNFC passed the evaluation organized by Indian Nuclear Science and Technology Bureau. 2009 July, our company, ThEC NPC, NPIC, and AECL for partners signed the advanced CANDU fuel development and demonstration phase 2 agreement. Our company is responsible to develop, fabricate, and supply to thorium dioxide bundles. The content agreement includes two phases. The first phase has finished. Now we carried on the phase 2. Our company's aim is to develop the commercial manufacturing technology for thorium-based fuels and to develop all kinds of thorium-based fuels for different reactors gradually. And finally, is to build up a research and fabrication center for thorium-based fuels in China. Second is the powder preparation. Thorium oxalate raw material through coenzyme dissolve, extraction, precipitation, filter, washing, drying, and calcine will get nuclear-grade thorium dioxide powder. In this process, the 6 process steps should be coordinated. First is the calcination process of raw material. the temperature and the holding time is the key parameters. With the temperature increase, the powder obtained dissolution rate increases. But if temperature is too high, the powder will agglomerate and the dissolution rate decrease. Our studies show that 600 degree is suited for dissolution. About holding time, with decreasing thorium oxide decomposes completely, and the dissolution rate of powder increases. But if the time increases further, dissolution rate couldn't grow. It is certain that 600 degree and 3 hours is suitable for dissolution. Second is the dissolution process. Results have shown under same conditions, concentrated nitric acid content increases. The solubility of powder is enhanced. And when dissolution temperature and time increase, solubility changes similarly. So many experiments, now we have determined optimum process conditions for these 4 factors. They are content of the concentrated nitric acid, dissolution time, dissolution temperature, the time, and the hydrofluoric acid content. The third is the precipitation process of thorium oxalate. Using thorium nitrate solution as raw liquid, we adjust the pH value of solution by ammonia. This process can remove rare earth impurity effectively. Fourth is the extraction purification process. Now, the single-stage extraction purification experiment of thorium nitrate was carried out. The third phase was well controlled during extraction, and the serum was separated with thorium. The fifth, oxalate precipitation process. The solution treated by extraction stripping process should be preceded by oxalate in order to achieve the purpose of the further purification. In the process, the influence of the temperature is most important. Studies show that when temperature is 50 to 90 degrees, sedimentation and purification will go well. 6. The calcination process of thorium oxalate. In order to obtain thorium dioxide powder, thorium oxalate should go through calcination. Up to now, the optimal calcination parameters have been determined. This picture is the nuclear-grade thorium dioxide powder. About powder preparation technology, the present situation is the purity of a powder can be less than 99.9%. Thorium nitrate extraction solutions should be treated by 5% TBP kerosene used for extraction in order to achieve separation iridium and thorium. Thorium dioxide powder preparation pilot had been carried out, and the powder can meet the specification requirements. In the calcination state, including instruction, grading, and nitrogen protection steps, can be effective in removing water crystallization. Next is about pellet fabrication. First is the granulation process of the powder. The powder should be granulated, improve the particle density and the mobility. And the granulation process includes preloaded cake, crossing, and screen. From the chart, we can see the granulate rate increases rapidly with the pressure increasing. But as the pressure increases further, there is a certain degree of drop. Based on the result, we select 85 as the pressure for granulation. Second is the forming pressure of a green pellet. Thorium dioxide green pellet are fabricated by the traditional molding process. The lubricant is zinc stearate mixed with carbon tetrachloride. During the molding process, bidirectional pressing was used to improve the uniformity of green pellets, and can also reduce grinding amount of sintered samples. The important parameters that affect the gradation is the forming pressure. With the pressure rising, the grain density increases. When molding pressure is 150, the magnitude of the increase of grain density decreases. In addition to forming pressure, holding time is also an important factor. In experiment, we select 300 as the forming pressure in order to investigate the effect of holding time. From chart, we can find grain density are extended as the dwelling time increases. When holding time ranges to 20 seconds, the growth rate is reduced. That is, holding 20 seconds is enough to obtain higher grain density. 3 is the sintering process of pellets. First, we choose the crucible materials. We choose graphite and aluminum crucible respectively. The former lined with molybdenum and tungsten respectively, and the later lined with this powder. The experiment results show the graphite crucible sample's surface will darken, but the aluminum crucible, the sample's surface is smooth and the sample is translucent. Second, we study the grain density effect. As the grain density increases, there is a great degree of increase in the density of the sample, and the radial shrinkage and the vertical shrinkage decrease. About the sintering temperature, we selected 5 grain density and sintered them at 5 temperatures respectively for 4 hours. The follow chart is the sintering process, and from the right chart we can find with the time and the grain density increase, the relative density is increased. This picture is the pore morphology of a sintered pellet. We can see as the sintering temperature increases, the pore size grows down and the pores distribute more uniformly. We studied the effect of a powder surface area. We chose 3 kinds of powder. The result showed the surface area greater, the relative density of a sintered pellet higher. This picture is the microstructure of the pellet. With the left one, its average grain size is 2. The middle one is 4 to 20. The right, its average size is up to 15. The fourth is about physical and chemical analysis. In 2008, we have to establish 12 methods of chemical analysis on 48 elements, such as ICP mass ICP AES, and so on. By the end of 2010, we have established and optimized the method of physical and chemical analysis for thorium dioxide pilot. The fourth is radiation protection. From 2008, we have to get a lot of information about radiation protection of thorium, including thorium radiation characters, toxicology, and environment behaviors, elementary method of radiation protection, means for emergency and fluid push, and started to set up the method how to monitor and calculate the person exposure dose, environmental impact, and disposing the thorium waste during thorium-based fuel manufacture process. And by the end of 2010, the established and optimization of measures for radiation protection had been finished. So about the experiment, the thorium chemical test line had been equipped with dry and calcination system, dissolution field system, and the water treat system. Using it, we can carry out small-scale chemical experiments and have the ability to conduct medium-scale chemical experiments and products. Thorium pellet test line is equipped with mixing system, powder grading system, pressing system, and plate sintering system. The powder purity greater than 99.9%, and the pellet relative density greater than 95% TD has been manufactured. The appropriate method for physical and chemical analysis has been established related to power and pellets, and radiation protection has been monitored and studied. Two lines above not only can carry out process tests, but also have certain production capacity. Combining the fabrication capacity for few elements of power or research reactors, our company already had a certain capacity for large-scale production of thorium fuel. In addition, the relatively complete nuclear fuel research and production system in our company can provide a technical platform for research and develop thorium fuel. So we sincerely hope to carry out extensive exchange and cooperation at home and abroad in order to make some substantial progress in the field of thorium resources utilization. Oh, thanks.
Great. Thank you for this very nice presentation. I just wanted to quickly ask, have you made any samples of thorium oxide pellets with other mixed components within the ceramic?
No, we haven't sold in the equipment, so we can't do this experiment.